This is the Chapter 8, Section 1 lecture, and the topic is Production Choices and Costs, the Short Run. What do economists mean by the short run? Well, it's not defined by a number of days or any fixed length of time, but rather we define the short run as a planning period over which the managers of a firm must consider one or more of their factors of production as fixed in quantity. In other words, if at least one factor of production can't be changed, then it's the short run. And so what are factors of production? Well, we talked about three of them: labor, capital, and natural resources. And these three factors of production, or I like to call them inputs, are combined through technology to produce outputs. And so that's what this chapter is about. The factors of production and how they're combined, and how they're combined into output. So in the short run, we can't change one of them. A good example of distinguishing between the short run and the long run would be to consider a production process where we have workers, machines, and the factory. So in the short run, we can adjust the number of workers and the number of sewing machines that they use. Right? You can easily go out and buy another sewing machine or hire more workers. But we cannot easily go out and buy a bigger factory. That would take time to shop around and find a factory that's adequate, and then take time to write the contract up and so on. So that would be a long-run decision. But the short run is one where one of those is fixed. In this case, the factory is fixed. Here we're talking about the production function. And what is a production function? Well, it's a relationship between inputs, or factors of production, and outputs. And so you can think about it like this. Given some inputs, or factors of production, land, labor, and capital, by land I mean natural resources, these are combined through technology, and this function F can be thought of as the technology. And then you get output. So 3 workers, 1 machine, 1 factory is going to give you 10 jackets. Something like that. Now, later on in this chapter, even in this very section, we're going to be looking at the cost of producing outputs. And we're going to look at not production functions, but cost functions. And when we do that, in about 5 minutes, we're going to see that cost of production is a function of output. So we're going to look at 2 types of functions in this section. And notice the left-hand side of the first one is the right-hand side of the second one. So here's a graph of the production function. And notice here we're calling it total product. This is just another word for output. And what is our output? It's jackets. So again, a production function relates inputs to outputs. This is telling us how if we vary the number of inputs, units of labor per day, we can get more output. Now, the shape of this production function is important, and a lot of the chapter, this section of the chapter is spent explaining the reason for this particular shape. So notice that as we go from 0 to 1 workers, we produce 1 jacket. And as we hire more workers, so we go from 1 to 2 workers, production goes up even more. Right? And the fact that the curve is increasing at an increasing rate like this means each additional worker we hire adds more to output than the previous worker. In other words, this is called increasing marginal returns. And why might that be? Well, imagine you have 1 worker in the factory by himself. He goes over to the fabric, cuts it, goes over to the sewing machine, sews it together, and then he goes over to the boxes and stacks the finished product in the box for shipment. So how many can he make? Turns out only 1 shirt per day when he has to do every single thing himself. But let's say now we hire a second worker. Together, how many do the 2 workers produce? 3. So the 2 workers working together can produce more than they each could produce working separately. And you might intuitively understand the reason for that. I like to call it synergy, because people can work together, and this is also called the division of labor. And it's a very important reason for why capitalist economies are successful, because market economies facilitate the division of labor. But here we see it in a factory, that when we hire more workers, we can have synergies and increase output by a lot. Likewise, when we hire the third worker, total output is 7. So we keep producing more at an increasing rate. And maybe so when we have 3 workers, one specializes in cutting the fabric, the other specializes in sewing the fabric together, and the third specializes in putting it in boxes and shipping it out. And so people can focus on one task, and then output can grow at an increasing rate. But eventually what happens, we hire the 4th worker, and we still get extra output out of him, but not as much as we did before. And why might this be? Well, with 4 workers, the factory is so small, they start to bump into each other. And the same thing with 5 workers. Adding the 5th worker, we still get more output, and the 6th worker and the 7th worker continue to increase output. But what happens when we hire the 8th worker? Output actually falls. And so that means you would never want to hire the 8th worker, right? You never actually hire someone to make your output go down. So we've spoken about increasing returns, diminishing returns, and negative returns. I was just highlighting these 3 concepts for you in the context of our jacket example. What about costs? All right, so you have a factory and you hire workers. That costs you money, right, if you're the owner of this factory. So what we're going to do now is say, take our production function as given and look at what is the cost of producing various levels of output. So we've already seen how workers and machines can be combined to produce output. Now we're going to look at how the cost of producing that output varies with how much we're producing. And so there are a couple concepts here. Total costs is just like it sounds, are the combination of total variable costs and total fixed costs. And so these concepts are pretty simple. It begins to look like alphabet soup a bit in this chapter, but generally there's only a few concepts, and if you can keep track of them, this will be easy for you. So fixed costs are the costs of the fixed inputs. And so in our example of this jacket factory, what were the fixed inputs? The machines and the factory. And then what are the variable outputs? The labor. Let's assume that the machines are fixed and the factory is fixed. And so then the only thing we can change is labor. So how much you have to pay the workers is your total variable cost, and how much you have to pay for your factory and the machines is total fixed cost. So that's it. Okay, so let's calculate total variable cost for different levels of output. If we hire one worker, assume we have to pay him $100. If you recall from when we looked at the production function, how many jackets can one worker produce? 1. So if we want to produce 1 jacket, we need to hire 1 worker, and we need to pay him $100. Right? So for 1 worker, we pay $100. Now, what if we want to produce 3 jackets? We need to hire how many workers? 2 workers. Right? We hire a second worker, now all of a sudden we can produce 3 jackets. And so what will our total variable costs be for hiring 2 workers? $200. Assume we can hire as many workers as we want for $100 each. So the total cost is $200 if we want to produce 3. And so on. Now, here's one thing that might be hard for you to note if you're just reading this. How much does it cost to produce 2? Well, if we're talking about hiring full-time workers only, then we can't produce 2. We can either produce 1 or we can produce 3. Right? But if we relax that assumption and we say, okay, you can hire part-time workers, well then maybe you need to produce 2, maybe 1.5 workers. But we don't have this from our production function, so we have to estimate it. And in fact, that is what happens later on in this section. So if you're curious where those numbers come from for these in-between quantities that aren't given on the production function, they're just estimated. So there's really no way that you would know that just by reading. And so we have, if we combine these points, the black points, again, are from our production function. The gray points are estimates. It looks like this. And the reason for the shape is exactly the same reason is a result of the same forces that are behind the shape of the total product curve. In particular, when we begin to increase production, starting at 0, when we begin to increase production of jackets, total costs rise. But the increase is getting smaller and smaller, right? For a while. But once we get to here, as we start to produce more, total costs continue to rise, but now they rise at an increasing rate. In other words, the slope is getting steeper. And so the costs begin to rise at an increasing rate. And this is a result of the production technology, where at first we had synergies with labor, and then later on we had too many cooks in the kitchen. Now, what about the total cost curve? Well, total costs are just variable costs, which we just discussed, plus fixed costs. And fixed costs are $200 no matter how many you produce. If you produce 0 jackets, you still have to pay for the factory and the machines. Your total costs are $200. If you produce 1 jacket, you still have to pay for the machine and the factory, $200, plus you have to pay for 1 worker, so total costs are $300, and so on. The whole entire total variable cost curve is shifted up, and that's the total cost curve. All right, so that is the overview of this chapter. So we've discussed the total product curve, the production function, and the total cost curve, the cost function. And everything that we've briefly discussed is summarized here in this table at the end of the chapter. And so you might even start by looking at these key takeaways before you read the chapter. And so the total product curve, initially it's increasing at an increasing rate. Then it's increasing at a decreasing rate. And then finally it's just decreasing. So here we have increasing marginal returns, the synergies. Here we have diminishing marginal returns. We have people starting to run into each other, too many cooks in the kitchen. And then here we have a serious too many cook in the kitchen problem. Our total costs reflects these costs. Right? Initially, the more workers you hire, the more each additional worker produces. So costs are increasing, but at a decreasing rate. But eventually we get to this point of diminishing marginal returns, and the more workers we hire increases our cost at an increasing rate. So the reason for this shape is because of the production technology. Now, in this chapter, like in the last chapter, we want to use marginal thinking to make decisions. And also a very important reason for doing this, on the right-hand side, calculating the marginal and average values, is because we're going to use this in the next chapter. So it might seem like not clear why we need you to calculate marginal and average right now, but it will later on be more apparent. So let's figure out how to calculate these, and then we'll discuss the shapes of those curves. Here is a list of all the formulas that you need to know. It's not asking too much of you, actually, to have you memorize these, because there's only a few different types of formulas here. It looks like there's 1, 2, 3, 4, 5, 6, 7, but there's really a few that if you understand, you can understand them all. Plus, you can always open your book, right, if you need to remember these. So we talked about this one. Total costs are total variable costs plus total fixed costs. Let's then look at the next average total cost. This is just total cost divided by quantity. Or another name for this is cost per unit. We're going to mainly refer to it as average total cost, or ATC, but it might be more intuitive for you to think about it as cost per unit. So it's an average. And whenever you see average, you see it also here, and also here, you're going to be dividing, so AP sub L is average product of labor. And you could think about this as how many jackets per worker. Finally, we have a fourth average fixed cost, and this is total fixed costs divided by quantity. So what were our fixed costs in our example? $200 for the factory and the machines. $200. And so if we produce 1 jacket, average fixed costs are $200. 200 over 1. If we produce 2 jackets, average fixed costs are 200 divided by 2, or 100. So that's an example of average fixed costs. So we've talked about the averages. We've talked about this relationship. The only two that remain are marginals. We have the marginal product of labor and the marginal cost. So MPL is marginal product of labor, and it's the additional output from hiring additional workers. This is a useful quantity to calculate, and because we can summarize the notion of synergies and too many cooks in the kitchen with the concepts of increasing marginal product, diminishing marginal product, and so on. Next and last, we have marginal cost, and this is the additional cost from producing additional quantity, additional output. So just to reemphasize, this is the marginal product of labor is a derivative of the total product curve, the production function. Marginal cost is a derivative of the total cost curve, the cost function. Okay, so now what I'd like to do is go through the example in detail from the book. This figure 8.2 gives you almost all of the information that you need to draw the total product curves, the total cost curves, and all the derivative curves, the average product, marginal product, average cost, and marginal cost curves. So everything that we want to do in this section of the chapter, we can do with this information here. It turns out we'll need two additional pieces of information. That is the amount of fixed costs, and it turns out it's 200, we assume. And also we need to know the cost of hiring a worker, and that is $100. So with those two pieces of information, fixed costs are 200, cost of a worker is 100, and this information, we can create all the other figures, and so that's what I'm going to show you how to do. Alright, so I'm going to show you how you can take the information in this table and the facts that worker costs $100 and total fixed costs are $200 to derive every single curve in this section. So to begin, set up a table like the one I have shown here and fill in the information from figure 8.2. So with 0 units of labor, we produce 0 jackets. With 1 unit of labor, we produce 1 jacket. With 2 units of labor, we produce 3 jackets. And I'm just going to fill in the rest of the chart now. Okay, so we have labor going from 0 to 8, and total output of jackets going from 0 to 10.5. You might notice that it would be appropriate to call labor inputs. You could talk about the quantity of labor, quantity of workers. It would be also appropriate to call this output of jackets, quantity of jackets. So we could call them both quantities. So therefore, I didn't use the term quantity here. I say labor inputs and outputs jackets. So we can calculate at first the marginal product of labor and the average product of labor. Let's recall the formulas for those. So the marginal product of labor is the change in Q over the change in L. And so notice here, as we go from 0 to 1 and then 1 to 2, what's the change in L always? 1. So you can just think about this as the change in Q over 1 if we're going from 0 to 1, 1 to 2, and so on. Sometimes we might go from 0 to 1 and 1 to 3 or whatever. So that's why this might not always be 1, but in this case it will be. So what's the marginal product of the first worker? 1. So we go the change in Q, delta Q is 1, right? This is 1 minus 0. And what's the change in labor? Also 1. 1 minus 0 is 1. So the marginal product of the first unit is 1. I'm putting it here in the second row. In the book, they would put it in between 0 and 1. And if you do it that way, if you put it in between 0 and 1, your graphs will look better. They'll line up perfectly. But if you put it this way, they won't. But it's kind of a technical issue. It's not really the most important for understanding the concepts. But just to alert you to that. What's the marginal product of the second worker? The answer is 2. And why is that? Well, what's the change in Q? We go from 1 to 3. So it's 3 minus 1. Change in Q is 2. And what's the change in labor? Again, 1. So the marginal product of the second worker is 2. The marginal product of the third worker is 4. The fourth worker adds 2 units. The fifth worker adds 1. The sixth worker adds 0.7. Seventh worker adds 0.3. And then the eighth worker actually reduces output. So this person is causing everyone else to produce less. And he's not adding anything himself. So the marginal product is actually negative for this last worker. Oh yeah, thank you. Okay, now what about the average product of labor? The average product of labor is total output divided by total workers, total inputs. And so when we're producing 1 with 1 worker, average is 1. When we're producing 3 units of output with 2 workers, average is 1.5. Here, the average product is 7/3. I'm getting a little bit lazy here, so I'm not going to solve these fractions. This one I can do. 10 over 5 is 2. 10.7 over 6. 11 over 7. And then 10.5 over 8. This is 10.5 over 8. Okay, so we've just derived the marginal product of labor and the average product of labor from the total product curve, or the production function, which relates inputs to outputs. Now, let's calculate total cost. The total cost function relates total costs to output. So when we're producing 0 jackets, what's the total cost? You might think 0, but you'd be wrong, because it's 200. Even if you're not producing anything, you're still paying rent on your factory and machines. So when you're producing 0, total cost is 200, because you still have to pay the fixed costs. Now what about when you produce 1 unit of output? Total costs are 300. Why? Because to produce 1 unit of output, not only do you have to pay for your fixed costs of 200, but you also have to pay for your 1 worker, and that costs 100. So total costs of producing 1 unit of output are 300. What about total costs of producing 3 units of output? Well, how many workers does it take you to produce 3 units of output? 2. So that costs, your wage bill would be 200. In other words, your total variable costs are 200. Your total fixed costs are 200. So your total costs are 400. And you should be able to see the pattern here. So the point is, here we're increasing workers by 1, right? So our costs are going up by 100. Our output is not necessarily going up by 1. We've just calculated total costs. Now, let's calculate marginal cost and average cost. To do that, I want to fold this like so. So the reason that I'm folding this is because we've already calculated total cost for all units of output. And so when we calculate marginal cost, we don't care anymore. We don't need to know, at least, how many workers were hired or anything else. We just take the total cost and we use that to calculate marginal and average. So again, what are our formulas? Marginal cost is change in total cost over change in quantity. So that's what we need right now. And then later on we'll need average total cost, which is total cost over quantity. So the formula for marginal cost equals change in total costs over change in Q. So here we have, when we go from 0 to 1, what's the change in total cost? 100. And what's the change in output? We go from 0 to 1, So the change is 1. We go from 0 jackets to 1 jacket. Our costs rise from 200 to 300. The marginal cost of that first unit was 100. The total cost was 300, but the additional cost of adding 1 unit of output is 100. Now, if we go from 1 to 3 jackets, total cost rises by 100. So the change in total cost is 100. But what's the change in quantity? 2. Again, we have a change in total costs when we go from 3 units of output to 7 units of output of 100. But the change in output, so the change in total cost is 100, but the change in output is 4. So what's happening to our marginal cost? It's 100, here it's 50, here it's 25. So our marginal costs are falling, right? Let's see if they continue to do so. So we go from 7 to 9, total costs increase by 100, and we get 2 more units of output. So the marginal cost is 50. Now the marginal costs are starting to rise. Too many cooks in the kitchen. When we go from 9 to 10, total costs increase by 100, output increases by 1, marginal costs are 100. Here we have 100 over 0.7. Here we have 100 over 0.3. And then here, we don't even need to really consider it, this 10.5, because think about it. If we wanted to produce 10.5 units, would we hire 8 workers? No, we would hire 6 workers and get 10.7, right? So this worker will never get a job. We will never be associated with this. So we don't have to even consider this. Okay, so we calculated marginal cost. And then we'll calculate now, finally, average total cost. So what is average total cost when we're producing 0? 200 over 0, which is not defined, right? You might say it's infinity, but better to just think about it is we can't do it because you can't divide by 0. So let's consider average total costs when output is 1. So total costs are 300. We have 1 unit of output, so average total costs are 300. The cost per unit is 300. What about when we have 3 units of output? Total costs are 400. We're producing 3, and so this is 133.33. That's the cost per unit. Finally, well, not finally, let me just do the rest of these for you. So I'm not going to solve all these out for you, but what you'll see is that average total cost is falling and then eventually rising. Okay, so this is how you calculate. The only ones that we didn't do would be average variable cost and average fixed cost. But other than that, we've calculated now all of the values that we see here. All right? So the last thing I want to do in this lecture is show you the graphs of what these look like. And we'll do that in 2 ways. First, we'll look at graphs from the textbook, and then we'll look at doing this in Excel. So again, we have total product curve, and then the derivatives of that, marginal product and average product. So notice the following. When total product is increasing at an increasing rate, then marginal product is increasing. And so that is called increasing marginal returns. But eventually, total product begins to increase at a decreasing rate, and so we have diminishing marginal returns. This is not really a bad thing necessarily. It just means, you're still producing more at least, right? The more workers you add, you're still producing more. Marginal product is still positive here. It only gets really bad when you get into the negative territory. So this is called diminishing marginal returns. Despite the diminishing you might think is negative, it's actually not as bad, right? Negative marginal returns literally mean adding another worker lowers output. And notice the marginal product is above average product until here, and then they cross. After they cross, marginal product is below average product. Before they cross, average product is rising. After they cross, average product is falling. That's a mathematical fact. And the way to see it is to consider your grade point average. Your grade point average is like average product. And the grade you get in, say, this class is your marginal product. So if the grade you get in this class is above your grade point average, what will happen to your grade point average? Will go up, right? So that's like we're here. Your grade point average might be like 3.0, and then you get an A in the class, so your average is going to go up. But what happens if the grade you get in this class is lower than your grade point average? Then your grade point average will go down. And that would be the case like we're over here. Your average is 3.0, but you get a C in this class, and so that brings your average down. We've also spoken about cost curves. The cost curves come directly from the production function, but we have to know the price of the inputs, the price of labor, the price of capital, and so on. So at first, total costs are increasing at a decreasing rate. That's because of the synergies we've talked about before. Then total costs are increasing at an increasing rate. That's because too many cooks starts to set in. Notice what we did in the, on paper a few minutes ago was we calculated average total cost and marginal cost. So let me just dwell on those for a moment, and we'll come back to these other two. So just like the grade point average example, when the marginal cost curve is below the average total cost curve, average total cost is falling. Then they cross. And then when marginal cost is above average total cost is rising. Again, that's a mathematical fact. All right? So it's important to know that. In other words, average total cost is at a minimum where these two curves intersect. That's an important point. When marginal cost and average total cost intersect, average total cost is at a minimum. That's an important point to remember for this chapter and for subsequent chapters. Now, the reason for that, again, is a mathematical fact. Why is this curve shaped like this? It's not so much a fact as an empirical regularity. So in other words, it's something that we observe. We tend to observe it. And so it's not that it could, not that it always has to look like this, but usually it will. All right. On the other hand, the fact that marginal cost intersects average total cost at its minimum point is a mathematical fact. Okay, so then the last thing we'll do here is look at this example in Excel. The data we need would be this production function data combined with the cost of labor and the cost of the fixed inputs. But we've already done that on paper, so I'm going to jump ahead to figure 8.5. Okay, so we have total variable cost at all units of output. If we add fixed costs of 200 to each of these, we'll have total costs. So now I'm going to transport this data into Excel, and I've already done that, and you see that here. So for example, to produce 0 costs 200, to produce 1 costs 300, to produce 3 costs 400, and we interpolate that to produce 2 costs 363. Okay, now let's calculate the cost derivatives. One is marginal cost, average total cost, average variable cost, and average fixed cost. So to calculate the marginal cost, we're going from 0 to 1. And so here's how you can write it in Excel code. Type equals, open parentheses, click cell C2 with your left mouse button, minus cell B2, close parentheses, divided by, open parentheses, click cell C1 with your left mouse button, minus cell B1 with your left mouse button, close parentheses, equals. And so why is it 100? So why is marginal cost 100, and what was that code that I just typed in? Remember, the formula for marginal cost is change in total cost over change in Q. And so when we go from 0 to 1, the change in total cost is 100. And the change in Q is 1. And so The code that I just typed in calculated 100 for us. Here is a handy thing about Excel, however. Once you type that in, you put your cursor on the bottom right corner until you get this little black cross. Hold down the left mouse button and drag it over, and look what happens. This formula, C2 minus B2 over C1 minus B1, Excel knows that you want it to update that formula. So in the next cell, you have D2 minus C2 divided by D1 minus C1. And so it will automatically calculate everything for us. We can graph this to see how it looks simply by highlighting it, clicking Insert, and then we can choose either line or scatter. Let's try scatter. So you see it has this shape. It has almost a U shape. Right? Okay, but before we spend too much time talking about the shape, let's calculate these other quantities. So what is average total cost? The formula is equals total cost over Q. So we don't probably want to calculate it for Q equals 0, right? Because it's going to be some number 200 over 0. So let's start in this cell here. In Excel, type so it equals, click cell C2 for total cost, divided by quantity in cell C1. So the average total cost when you're producing 1 is 300. Let's see how this changes as we increase production. We see that average total cost falls and eventually rises. What about average variable costs? Here we have equals. Well, let me back up. Okay, so what are average variable costs? Average variable costs equal total variable costs over quantity. But are we given total variable costs? No, we are not. However, we do know the following relationship also exists. Total costs equals total fixed costs plus total variable costs. So we can rewrite this. Total variable costs equal total costs minus total fixed costs. And do we know the total costs for every unit of output? Yes, we do. Do we know the total fixed costs for all units of output? Yes, we do, and that value is 200. So all we have to do is subtract 200 from every from the total cost for each quantity. In other words, we could do it like this: equals, open parentheses, total costs in cell C2 minus 200 divided by the quantity, and we would see that we have the following. Now, there's another way to do this, and rather than writing 200 in here, we could click the total cost at a quantity of 0. But watch what happens if we do it this way and then drag it over. We go from the formula C2 minus B2 over C1, and then when we drag it over, we get D2 minus C2 over D1. But that's not what we want, because we want it to be D2, that's total cost, minus total fixed cost, which are not 300 but 200. In other words, we don't want this to become C2. We want this to remain B2 as it was in this formula. So we want this B2 to stay the same, but we want this number and this number to be increased automatically. So how do we do that? Well, we use a technique called cell referencing. So this dollar sign, putting the dollar signs in here is called cell referencing, and it's a valuable spreadsheet skill for you to know whether you use Excel, Numbers, Calc, or any other spreadsheet. The code tends to be the same. The last thing that we'll do is calculate average fixed cost, and we'll make use of cell referencing again. So the formula for average fixed cost is fixed cost divided by Q. And so we know that fixed costs are 200, right? So we could just write equals 200 divided by the quantity, which is in cell C1. And we see that total fixed costs fall over all units of output. Another way we could do this is, rather than just saying 200, we could type B2 and then use cell referencing. I admit that it's not any easier to do it this way here, but it does highlight that useful skill. Okay, and then so if we want to see what these look like, we can just graph them. Insert. I said we can use either scatter or line. If you use scatter, you have to select the one that looks like a line. But if you want to use line, just select the first one. And then the only thing that's wrong here is that these numbers need to be updated. So right-click, click Select Data, and then edit the horizontal axis labels, highlight them. Click OK, and then OK. And what you noticed happened is the horizontal axis changed. So we start from 0, and then 1, 2, 3. Total cost, obviously, is a lot higher than all the averages and marginals, right? That's because the cost per unit, if you're producing 1 million units, the cost per unit might be $1, but total costs are $1 million, right? So there's a big difference between these averages and total costs. If we want to focus on the averages and marginals, we can delete this and then see, this is the marginal cost curve, right? This red curve. It intersects average total cost at its minimum point. Now, if I had put the marginals in between 9 and 10, like they do in the book, then it would really intersect average total cost at the absolute minimum point. In fact, it's actually decreasing for like a little bit more. You can't really see it here. So, like I said earlier, it's a bit of a technical reason to put the marginals in between them. If you do it like I do, your graphs won't look as perfect, but they're pretty darn close, and you can't really tell by looking at it, so it's good enough. The relationship between average variable cost is the same in that the minimum point is where marginal cost intersects it. Finally, average fixed costs are just falling. Why? Because you have $200 worth of equipment. The more you produce, the more the cost of that equipment is spread out over more units. All right, and so that's how you can look at these cost curve relationships in the spreadsheets, also on paper, and also in graphs.